I'm Anil Kumar. Welcome to my mathematics series with Amy. Amy is a bright student from London, UK. We have an excellent strategy to understand the concepts and bring them to you. What we are really doing is first getting into the details of every topic and then selecting the best questions which have appeared in past test papers. Hi, Amy. How are you doing?
Hi, sir. Yeah, I'm good, thank you. How are you?
Very good, very good. So today, what do you want to do?
I thought we could just maybe review a couple exam questions in real time, just kind of look at how to answer a couple things and alternative methods as well, which would be interesting.
So you can share your exam questions. Let's see how we can answer this. So
Yes.
what is the question for you? Yeah, read the question.
All right. So the value of a rare painting V pounds is modeled by the equation V equals PQ to the power of T, where P and Q are constants and T is the number of years since the value of the painting was first recorded on the 1st of January 1980. Okay. The line L shown in figure 3 illustrates the linear relationship between T and log 10 of V since the 1st of January 1980. So the equation of the line L is log 10V, which equals 0.05T plus 4.8. Mm-hmm. Part A, find to four significant figures the value of P and the value of Q.
Correct. So we are given that the line L shows this illustrates. So we are given that the equation is log of, so base is 10 by default, V equals 0.05 T plus 4.8. So at T equals to 0, the value is 4.8.
Yeah.
So it is find the value of P and Q to this. Okay. So if I put V equals to 0, if I put T equals to 0, I get V equals to, for T equals to 0, in this particular equation, T equals to 0, I get the
V equals P.
V equals to P. So at T equals to 0, V equals to P. So that means log to the base 10 of V, we know is 4.8, correct? Correct?
So
at T equals to 0. So V equals to 10 to the power of 4.8.
So this is all at 10 T equals to 0. Okay.
So yeah, initial values of this graph is 4.8. So at T equals to 0, we get the value of log of V as equals to 4.8, right?
Mm-hmm.
So if I put T equals to 0 in this equation, let's call this equation as 1, then V equals to P. Now the value of P should be, the initial value that is, 10 to the power of 4.8. So how much do you get? 10 to the power of 4.8. So that is the value.
63095.73. Yeah.
So you want till four significant figures. So 63095.
63100.
100. Yeah. So that is what you get as your answer. Is that clear?
Yeah.
Now part B is find the value of Q, right? So find to four significant values P and Q. Now how will you find value of Q? So you can now use that at 10, some other value, right? So because you have given the equation this, so at, so you can put V equals to, we know P, Q over, so we have this equation, you can put some other value of T. So let us say the value of t is, since 1st January, t is equals to, give some value. Let us say it's a linear function, 10, for example.
Yeah.
And then you can calculate the value of v. And t equals to 10 there, and you can find the value, right? So we can give a value of, let's say, 2 or 3. Let's say t equals to 2. So calculate at t equals to 2, put t equals to 2. So if I put t equals to 2, I get log of v equals to 0.05 times 2 plus 4.8, correct?
Yeah.
So from here, you can calculate what value you get. So you get v equals to, what is this?
4.9.
Yeah.
10 to the power of 4.9.
Yeah. So you get 10 to the power of 4.9 as the value of v for t equals to 2. So you can put this value here, 10 to the power of 4.9 equals to, p is already known to you, 10 to the power of 4.8, correct?
Mm-hmm.
10 to the power of 4.8 times q square, because we put t as 2, right? So q square. We could put 1 also. Anyway, we'll put 2 square. And then we can find the value of q as 10 to the power of 4.9 over 10 to the power of 4.8 equals to q square.
Q squared, yeah.
Right? So 4.9 minus 4.8 will be 10 to the power of 0.1.
0.1.
And square root of this will be q.
10 to the power of 0.1. And then square root, we're doing plus or minus?
We'll be positive. Positive values.
Yeah. So I'm getting 1.122 for SF.
Yeah. So that is the rate at which it is increasing. Okay? So that becomes the value of q, and that is how you're going to find the two answers.
And then you just sub it back in and get p.
No, t is a variable, right? Yeah, p we know, p is a constant, 10 to the power of 4.8.
Oh, yeah.
So, but decimal values you can calculate. So we get p as equals to 10 to the power of 4.8 and q as equals to 1.1222. Is it okay?
Yeah.
Right. So 1, 2, 3, 4, 4, 6, right. 2 2s. So that will be your answer.
Mm-hmm.
Now let's do the other parts.
So with reference to the model, interpret the value of the constant p and the value of the constant q.
Oh, we calculated.
Yeah, but reference to the model. So does that just mean like
interpret, right? So
yeah.
So the value of p, so we had v equals to pq t, right? So
yeah,
p is the initial value.
60. Oh yeah, and q is the rate at which.
Yeah.
It increases in
rate
relation
of increase,
to t.
right? So q is rate of increase. Q is growth rate.
Oh, growth rate. That's the word I was looking for. Yeah.
Growth rate or rate of increase of this particular painting cost, right? Growth rate.
Right.
Or rate of increase, you can say. Per year.
Per year after 1980.
1980. Correct. That is how you'll interpret. Yeah. So is this clear to you?
Yes, sorry. So it's just a little bit, I don't know, kind of just, yeah. I think when I did this, I kind of struggled on. So I got the t equals to 0, but then to find the other point, it could have been any point. It's just I don't know. I was just looking at the graph and there was no values given, and I felt a bit like, oh, so all I needed to do was kind of sub in any value at that point.
Correct.
Like you did too. So yeah.
So actually, from here you understand one more thing. We were actually given the equation. This v equals to p d to the power of t, right? So this is a standard method of writing these exponential functions as logarithmic functions and getting a linear graph as you've got. Because interpretations from the linear graph are much easier and very accurate also. So if I take log both sides, what happens? See, if I take log both sides, I get log of v equals to log of p times d to the power of p. Is it okay?
Yeah.
Applying the logarithmic rules, we get log of p plus log of d to the power of t. And that gives you log of p
T
plus
plus T
log
log
of
D.
t. Do you see that?
Yeah.
Actually, we get a linear curve y equals to mx plus b's form. Do you see that? This is log of v. So we have taken, compare this with y equals to mx plus b. Right? So if you compare with y equals to mx plus b, so you see this is y, which is log of v.
Yeah.
And the rate of change times the variable t, right? So log of d, let me write like this. Log of d is rate of change, right? And then it is time, the variable, plus the initial value, log of p.
Mm-hmm.
You get the idea. So basically, this is the log of p value, initial value.
Oh, so log of...
And this is the rate, rise over run. You understand? Rate.
Oh, yeah.
Where time is the variable t. Do you understand this whole concept? So that point was 4.8, correct? So directly also, I can now interpret this. Log to the base 10 of p is 4.8, correct?
Mm-hmm.
From that equation. So p equals to 10 to the power of 4.8. Do you see we got the same result?
Yeah. I think for me, I kind of need to do what you like the layout and make it relate to y equals mx plus c, because I don't know, I found it hard to get my head around that one. Okay. Yeah. So take logs on both sides.
You're right. So you are given this equation. Sometimes the question would be model this as a logarithmic linear model. Equation could be modeling with the logarithms.
Yeah.
So then the equation is derived in this particular fashion.
Oh,
so
I see.
Now you sketch the graph where the intercept will be log of p, the initial value in 1980, and the growth rate will be log of d.
Right. Okay.
Variable with d. So this is another way of looking at it. Okay.
I see. Yeah.
Okay, let's have the next question, please.
Oh, I think there's one more part to this question. Yeah, find the value of the painting as predicted by the model on the 1st of January 2010 by giving your answer to the nearest £100,000. So we just need to find the number of years between that and then sub it in.
Yeah. So
30 years.
Since the value of the painting was recorded on 1st of January. You see the 1st of January?
Yeah.
So now 1st of January 81 will be after 1 year. So 1st of January 20 will be, you have to just take the difference, right? So this is 1980.
30 years.
Okay. So 30 years. So plug in 30 and get your value. You know both P and T, right? So use the formula. So you'll substitute this value as equals to 10 to the power of 4.8 times Q value is 1.122, I think, correct?
Yeah.
And T is 30. So you can use a calculator to calculate this value.
Oh, okay.
1.122 to the power of 30 times 10 to the power of 4.8.
Oh, no. 10 to the power of 4.8 times 1.122 to the power of 30. Yeah, big number.
Yeah,
so yeah, you want nearest 100,000.
Yeah.
So 199. Oh, you know what? I'm just gonna 1994278.
So you want nearest 100,000, right?
Yeah.
100,000. So it becomes 100,000. Is that clear?
100,000. Yeah.
100,000, right? 100,000. So 1, 2, 3, 4, 5, 6, 2 million.
Wait, when you say 100,000, I don't know. Wait, Am I being stupid? Or have had a long.
So this
like,
is 100. This is 100, and that is 1000. Do you see that? So you have to round to nearest 100,000. So it'll be 100,000. So because it was 94, we round 94 to next 100,000.
Oh, okay.
That's what it means.
All right.
So now we have finally done this 8-mark questions. Next question, please.
Well, 8 marks. All right. Okay. So we can skip this because I don't know if that's been learned.
Yeah. It's been a long time you've done this, right?
Yeah, long time.
Yeah.
Okay. Let's do question 3. Doesn't look that bad.
Yeah.
So find 3 significant figures, the value of x for which 8 to the power of x is 0.8. So just take logs on both sides.
Let's take log. X log 8 equals to log of 0.8.
0.8.
X equals to log of 0.8 divided by log 8. Correct?
Mm-hmm.
So let me do this.
Minus 107. The 3 significant figures.
Minus
107. Is it fine to write just log 8 in the exam, or do I need to write log like base 10, or they know what it is?
by default, it is base 10. So you need not be specific. There is no need to write log to the base 10. Right?
Okay.
So ln is natural log, which is to the base e. Is it okay? Ln x will be to the log e. Correct?
Okay. So just write that the ln x equals log base e to the x.
Correct.
Yeah. Okay, and then part B, solve the equation 2 log 3x minus log 3 7x equals 1.
Yeah, tell me how we do.
So the log rules of when you subtract, you divide. So you do log 3x 2 over 7x equals 1.
So this will be x squared, right? This
you have to move that first. Okay.
Over 7.
X squared over 7x equals 1.
So this is to the base 10. So x squared over 7x equals to 10 times 1. Is it okay?
Yeah.
So we get x squared equals to cross multiply 70x. Now, clearly, x has to be greater than 0, right?
Yeah.
So
can we move this 70x to the other side?
So yeah, you can move, right? So we have x squared minus 70x equals to 0. X is common, so x minus 70 equals to 0. So we get x equals to 70 as our answer.
Right.
So that is how you're going to do it.
And x cannot equal 0 because you can't do log of 0.
Yeah.
Yeah.
That is a restriction.
Okay. So that's clear.
Next question.
Let's find an interesting, a bit of trig.
Okay, let's do
trig.
it.
Yeah. It's kind of a weak spot for me, so let's work on that. All right, question 5a. Show that 10 sine squared theta minus 7 cos theta plus 2 over 3 plus 2 cos theta equals 4 minus 5 cos theta.
Okay.
So we want everything, like the right-hand side is in terms of cos, so you want to make sure to substitute the sine squared theta for 1 minus cos squared theta.
Perfect. So you do that part first. So we'll independently do numerator and denominator. So let's solve this, right? Plus 2. So we'll look into this numerator. So we get 10 minus 10 cos square theta minus 7 cos theta plus 2. And this could be written as, we can take minus 10 cos square theta. And that is minus 7 cos theta plus 12.
Mm-hmm.
You can take minus common, and then you can try to factor this, correct?
Yeah, so 10. Oh, should I use my calculator?
Yeah.
let's quickly find.
Or you can cross multiply and bring all terms together also. No, that also you could do.
Yeah.
You get, yeah, that also you could do.
When you take the minus out, it's 10 cos squared theta plus 7 cos theta minus 12. Yeah.
Correct. And we'll cross multiply this and we'll write that equal to. So we, on the other side, when we cross multiply, let me write this as 4 minus 5 cos theta times 3 plus 2 cos theta, right?
Yeah.
I wrote theta, but it was x, so write x and not theta, okay? So 4 times 3 is 12, and we get plus 8 cos, let me write now x. Let me continue with theta itself. Oh yeah, is theta in this one. So the other one is with x, okay, okay.
Oh yeah.
Okay, so and this is minus 15 cos theta. And that
So can you use the right-hand side to show that that's the answer?
Oh, I see. We could do that. Yeah. So we will factor this, correct. Let us factor this, sorry. Factor 10 times 12, yeah. So one of the factors will cancel. So you're left with 3 plus 2 cos theta.
I think one of the factors I'm getting is what's it called? 5 cos theta minus 4. You know the minus 10 cos theta squared plus 7 cos theta minus 12.
Yeah,
section.
so you need 120 and you need two numbers. So sum, this is what you need with negative product and sum of 7, right? So the two numbers could be what? So for example, you could have 12 and no, that will not work. So can you divide by 8? 10 and 12 will not work. So because we know if I divide by 8, find the two numbers.
I got, when using the calculator, the values that I get is x is minus 3 over 2 and x is 4 over 5. So if we put that back in the brackets,
you
the factor 4. Yeah.
Okay.
Otherwise, I'll be there forever.
Okay. Yeah, you could do like that. So what we do is you can just factor these kind of. Right?
Oh, okay.
So 15 and 8. Do you see this? 15 and 8?
Yeah.
So without calculator, see 15 and 8, right? So we'll split this into two numbers, which are 15 and 8. You get the idea?
Okay.
So we'll write this as minus 10. I'll write bracket here. 10 of cos square theta and plus, I'll write plus 15 cos theta plus 15, right? Minus 8 cos theta minus 12, correct? And now in these two, 5 is common. 5 cos theta is common. So we get 2 cos square theta. And we'll put bracket and with negative sign here. 2 cos 5 times 2 is 10. And 5 times 3 is 15, right?
Yeah.
And on this side, we can take 4 common. So we get 2 cos theta plus 3, correct?
Yeah.
Now 2 cos theta plus 3 is common. And we get, outside is minus, okay? And then we get 5 cos theta minus 4. 5 cos theta.
That's the other bracket.
Right? And we had the denominator. Now let me put the denominator, okay? So which is 3 plus 2 cos theta. Is it okay? So 3 plus 2 cos theta cancel, and you're left with minus of. Left with
that would be 4 minus 5 sin theta, 5 cos theta.
Which is 4 minus 5 cos theta. Is it clear?
Right.
Which is this?
And that's what we wanted to prove. Okay.
So Amy, can you describe this method once again?
So because it's a show that question, we're just trying to kind of show the answer that they've already kind of provided for us. So
start with left-hand side.
Yeah, start with the left-hand side. And by looking at the right-hand side, you can see that the answer is in terms of cos. So we want to make sure that if we have any signs on the left-hand side, we want to make sure to convert that to cos. So we saw that there was 10 sine squared theta. The sine squared theta can be written in terms of cos using the trigonometric identity. which is also equal to 1 minus cos squared theta. Then what we did was we dealt with the numerator first, just to avoid any confusion. And when we converted all of that, we had a negative outside. So we made sure to keep that like aside, and then just factorize the brackets. And then obviously the answer on the right-hand side is only like one answer, it's not over a fraction. So we know that there would be a common factor between the numerator and denominator, which would cancel. And then you can get your answer as we showed. So
do you remember what was the common factor in the numerator? Did you write that? No.
2 cos theta minus plus 3. No. Yeah, 2 cos theta plus 3. It just has to be that denominator, right?
No, one factor got cancelled. So that one, did you write?
Yeah, that was that one. 3 plus 2 cos theta.
The 3 plus 2 cos theta is okay. But when you factorize, what was the other factor?
5 cos.
Yeah, 5.
So it's a minus outside. And then it was 5 cos theta.
Oh, this one. This factor.
Yeah, basically that one. I'm just trying to think of it with the minus outside. Is it minus 4? Minus 4 inside. Yeah.
So basically, yeah. So what I'm trying to say is the numerator was basically 4 minus 5 cos theta times 3 plus 2 cos theta, right?
Yeah.
Times. So that cancelled.
But there was a minus outside.
Yeah, there was a minus outside.
Yeah. That's why.
Yeah, I wrote it without minus. 3 plus 2 cos theta.
Yeah,
okay.
But inside the brackets it was
correct. And so we found that was a factor. So 3 that cancelled, correct? So remember one thing, you have to write restrictions, right? So cos theta is not equal to minus 3 by 2. Right? So remember this, that cos theta is not equal to minus 2/3. Is that okay?
Oh yeah, and that should be the first thing we write, whether or not they ask for it. Yeah.
Correct. That is very important. And see, the second part is, hence or otherwise, solve for x between 0 to 360 degrees, this equation, right? The same equation, correct?
Yes.
So they slightly change this. Anyway, the left-hand side can be simplified to what I wrote, correct?
So I think, they're trying to make you solve it. So we'll just have to substitute that. Yeah,
So we'll write this as 4 minus 5 cos x equals to 4 plus 3 sin x. Is that clear to you?
And then we'll get tan.
So you will write this. And remember, your cos x cannot be equal to minus 2 by 3. So do not write your answers if you get that, right? I'm just that is the whole idea, right? So now we can bring 4 and 4 cancel, right? So we get so we get 3 sin x equals to 5 cos x, correct? You can divide by.
Does the minus?
Yeah, minus. Yeah, minus, correct? Minus. So now you can divide by cos, right? So you get 3, you get tan x equals to minus 5 over 3. Is it clear?
Yeah.
So, and within this particular domain, you have how many answers now? So negative tan, you get answers when it is in 2 different quadrants. Those are your quadrants, correct?
Yeah.
So you can find the value. If you want to find, you can find the related acute angle alpha, right?
So it would be tan inverse
of 5 by 3.
Yeah, which is 59.
Yeah. So equals to 10.
0.03.
Let's say 59 of x, tan inverse of 5 by 3 is 59. So the values will be these values.
180 minus that, which is 120.
Yeah. Got it.
120.96. So
121 degrees. And then add this, right?
And then you add, which would be 2 pi. So I'm thinking radians now.
No, degrees.
Yeah. 300 points. So 301.
300. Okay. So those are your 2 solutions for the given equation. Is that clear to you?
Yes.
Correct. So this is a very standard type of question which comes. You have to simplify in one part, apply that simplification to solve an equation. Okay.
Yeah.
So, okay, we can end our class here today.
Okay.
We can go further. We can go further. We still have time, right? We still
Yeah.
have, yeah, we are
7.
still, yeah, we can go further, right? Let's take up more questions.
Okay. Oh,
Yeah.
there's this one.
Okay.
Yeah. Okay, so figure 4 shows the plan view of the design for a swimming pool. The shape of this pool, ABCDEA, consists of a rectangular section ABD joined to a semicircular section BCD as shown in figure 4.
Right.
Given that AE is 2x meters and ED is y meters, and the area of the pool is 250 meters squared, part A, show that the perimeter P meters of the pool is given by P equals 2x plus 250 over x plus pi over x over 2.
Okay, let me this power. I have to put the power cord here. Just give me some time. Okay, we are given a pool, and we are saying that AE is 2x. So that means this radius is x, right?
Yeah.
Okay, and ED is y. The area of the pool is 250 meters square. So the rectangle area plus this. So area is equal to how much?
250.
2xy. Yeah, 250.
2xy.
Pi
Plus.
r square, right? So pi, x is the radius square and half of that because it's a semicircle. Is that clear?
Yeah.
And this is given to you as 250, correct?
Yeah.
So this is equal to 2. So get first equation. Perfect?
Yeah.
Now show that the perimeter P of the pool is given by that expression, right? So we need to find the perimeter. Okay. So for perimeter, we just need to find what this is. So solve for x. You need to find from this equation, eliminate y because we have y here, which we need to eliminate, right? Do you see the expression? We need to only find y in the first equation, right? So,
right. So should we make y the subject?
Isolate y. Is it clear?
Yeah.
So we'll multiply everything by 2. So get 4xy plus pi x squared equals to 500. So we have pi x squared. So y will be equals to, let's write
500 minus pi x squared.
Yeah. So okay. So y, let me read. Correct. So we have 4xy. Let me write this first. 500 minus pi x squared. And okay. Let's worry about 4x. Yeah, let's worry about the perimeter. Perimeter will be, we have to isolate y in any case. So we have y equals to 500 over 4x minus
500,
pi x squared over 4x, correct? So that gives you, so 500 when it divides into this, you get 125 over x minus pi x over 4, 1/4 of pi x. So you get this value of y, correct?
Yeah.
Perimeter is how much? This length of perimeter is equal to 2x, this length, plus 2 times y, correct? 2 times y plus 2 pi x, correct? That is what you get.
So 2 pi x you got from the circumference is pi d.
Yeah, half of this. So pi
half of pi d. Yeah.
So pi x. You're right.
Pi
So
x.
plus 2 times y value is now 125 over x minus pi x over 4 plus pi x. You need to simplify this. 2x plus
plus
you have similar expression, right? Let's multiply 250 over x. And when you multiply this, you get minus pi x by 2 plus pi
Yeah.
x. Right? So this gets simplified further. We get 2x plus 250 over x plus pi x by 2. Correct? That minus this. Perfect?
Yeah.
You get the same expression. So that is how you can find the perimeter.
Right.
So that is clear. We can now look into the next part.
Mhm.
Yeah.
Okay.
What is the next?
So explain why x can only be between 0 and 500 over pi square root.
Oh, so we actually got an expression there. I didn't really keep that expression. So y was equal to, we had one expression, 250 over
500. I wrote it down. 500 minus pi x squared over 4x.
this
Oh,
is
whole thing over 4x.
like this.
Yeah.
This was y.
Yeah. But you did simplify it, but I thought.
Yeah, but it has to be positive. Basically, this has to be greater than
0.
0, right? So in that case, the numerator cannot be negative, right?
Right.
So we have 500 minus pi x squared should be greater than 0. Is it okay?
Yeah.
So that means 500, we'll take pi x square is greater than pi x squared, correct? So you can divide by pi, so you get 500 over pi is greater than x squared, correct?
Mhm.
Now, since x is greater than 0, we can square root it, correct?
Oh, yeah.
So, otherwise, it will be absolute value of x, right? So you can square root it. So when you do it, so it is greater than x squared. That x value is between this and this. Is it okay? So
Right. Okay.
You get square root of 500 over pi is actually greater than absolute value of x. Is that clear? Because
Yeah.
when square root of a square is absolute value, correct?
Yeah.
So 500 over pi is greater than this. That means x is between 0 and this, because x is positive. Since x is greater than 0, so we get x is between 0 and square root of 500 over pi. Is that clear?
Yeah.
That is how you're going. So the relation which you just got actually helps to find the restriction.
Right. That's clear. Yeah.
Now,
Part C. Find the minimum perimeter of the pool, giving your answer to 3 significant figures.
well,
Minimum.
to find the minimum perimeter, what will you do? Derivative.
I feel
right?
like you can do calculus. Yeah.
Yes, you have to, right? So you'll differentiate with respect to x, correct? So dp over dx, figure this out.
So 2 plus, so that'll be 250 over
Minus.
minus 500 over x squared. Sorry.
Yeah, so minus 250. So let me write this as because
Plus
that is
250
minus 1, right? So minus
x to the power of minus 1
over x squared. And this will be x over 2. That means x plus pi by 2. Is it okay?
Oh yeah, where did I get minus 500 from? Sorry. Yeah.
Okay. So that is what you are going to get. Now you have to equate this to 0 to find the critical number, right?
Mm-hmm. Which would be
like
your stationary point. Yeah.
Correct. So we'll take minus term to the other side, which is 250 over x squared. That should be equals to 2 plus pi by 2. Is that clear?
Yeah.
So we can now cross multiply because we just are interested in finding what the value of x is, right? So you can calculate this value because we want it to some significant figures, right?
Yeah.
So you can calculate this value. What is 2 plus pi by 2 equals to?
3.5707, but yeah. 3.7.
So x squared is equals to 250 over 3.57, right? So x will be square root of this. So find square root.
8.36.
So 8.36 is the value of x, but you need to find the minimum perimeter, right? So substitute 8.36 here. So perimeter for x equals to 8.36. Substitute, find your answer. 2 times 8.36 plus 250 over 8.36 plus 5 times 8.36 divided by 2. Is it okay?
Mm-hmm.
Calculate this.
59.75. So 59.8 to 3SF.
Okay. Now, the idea here also is that you have to show that this is the minimum value. Is it okay?
Oh, so you have to use second derivative.
Yeah. So what? Yeah, you could use second derivative of the given expression. Where is your expression now? dp dx is this, correct?
Yeah.
So if you do the second derivative, then second derivative is, we do minus and minus, it becomes positive, right? So
Positive.
Yeah.
Positive 500 over x cubed.
So the curve is like this, right? So it is minimum.
Yes.
So d2p over dx squared will be equal to, that will be negative, negative, positive, 2 times 500 over x cubed. Is it okay?
Yeah.
That minus will become plus. So for any value, it is positive. So it is, curve is like this, right? You can hold it. You get an absolute minimum here. So at the critical point, you have a minimum. So that is how you'll also show. So this is kind of important part, to find the second derivative and show that it is a minimum. Is it okay?
Oh, I see. Yeah, yeah.
Yeah. You probably will get full marks if you don't show, but I think it is better to show. It just takes one more statement, but it's very important statement, right?
Because I think the keyword minimum, yeah, just to emphasize that part.
So this actually question was pretty good because, you know, can you explain what was so good about this question, Amy?
Because we've done a lot of calculus questions. It's just that this one, in terms of wording, it's quite subtle that you had to use calculus on that last question, because there's so many other maybe ways your brain could like go because of the way it started off as. So when we started off, it was just literally simple algebra, and we eliminated y in the first instance because when we looked at the perimeter equation, there was no y present. So that's why we got rid of that. And then we substituted the value of y we got into the perimeter equation by also using the value of the area given. And from there, we just kind of worked down and found the perimeter as shown. And then for part B, we just used the y value and made sure, because we want the numerator greater than 0. So in that instance, you would get the domain to be x between that boundary. And then for part C, that's when you use the first derivative. We derived that and found the value, but that wasn't done because they're asking for the perimeter. So we had to sub it back in to the actual equation that's given, and then we worked there. But as Sir said, just as a last step as well, just because it says minimum, just find the second derivative just to show that it is the minimum point, maybe. So that'll be good. Yeah.
So many
a lot of parts.
This is also a very important part, showing that that is your interval, right? Valid values of x. We got, when we isolated y as a function of x, we got that from this result, right? And you could also use, to prove minimum value, you could also use the boundary condition. So because it is the boundary between the two values, you could use the boundary condition, but the second derivative is very important. So let me write down here, second derivative to show minimum. Is that clear?
Yeah, so if for some reason you forgot about the second derivative, you can just use part B then. Is that what you're saying, to help?
I will not prefer that because it is not equal to. So the boundary is not equal to, right? Because x equals
yeah.
you cannot use it. So I said it, but yeah, it's good you reminded. It is not equal to. If it was greater than equal to, I could have used. but not
Oh,
above.
okay. So I'll keep that in mind. Yeah. So next time, if I have a like an interval that is equal to, then you can use one of the
Then you can
values.
use, yeah,
Oh, okay.
not otherwise.
I wouldn't have thought of that, even if it was equal to.
Yeah,
Yeah.
because you
Okay.
cannot put x equals to 0, right?
Yeah. No, because it would error. Okay.
That's the problem. Yeah.
Cool. That was all the questions that I had.
Okay,
It was
that's great.
just
So,
like,
Amy, can you summarize today's learnings? I'll end this sharing. So, you can end this sharing. Okay.
I think it was.
Yes, Amy. So,
Yeah.
what did you learn from today's lesson?
Yeah, so kind of a lot. Again, we started off with a bit of log. I feel like the questions are getting a bit more lengthier and wordier, so it's hard to like actually see the maths in it. There's a lot of English going on. But yeah, anyways, with the log, when we started off with, it was kind of just remembering our rules, understanding the graph, and I think the main point for me was getting that log into the y equals mx plus c form, which it was not given in the question. You kind of had to derive that yourself, you know, from log v equals p cubed to the power of t. So just working like that, which I would never have done. So once I saw that, you can see that log p was the initial, the other one was the rate of change. So you can see that if you did that. So yeah, that was really important, which I'll keep in mind. Okay. And then we again just worked with a bit of trig, trying to understand like the trigonometric identities, making the left-hand side equal to the right-hand side, and like proving that. And in terms of like the simple, like the classic question, you know, when we work with circles, we always know that classic like structure you have, especially for my kind of test papers. The same one is for the trig identities. They always say show that, and then they would do a follow-up part B using that maybe answer to find a different one, and then use the cast rule and find the related acute angle and things. And then after that, we did this final area question, which was had a lot going on. And as I explained, we did a bit of calculus. We found the domain, that interval, and just key points to remember is, so let's say you didn't just forgot about second differentiation and you needed to use a value, don't just like stop there, because it is maybe 5 marks. So you can look at your previous steps and see if it was greater than or less than equal to sign. If it's equal to, you can use that value to find maybe the next points, which was a good point.
Because when you have extreme boundaries given to you, you could apply that because within 2 boundaries you'll always have extreme value of the function, right? A minimum or a maximum. Correct? That is very important to understand. So I think that was nice, and we can end the class here today.
All right. Thank you so much, sir, for your help. I appreciate it.
All the best. Thank you.